A car is traveling at 52 kilometers per hour on a flat highway. If the coefficient of friction between the road and tires on a rainy day is 0.116, what is the minimum distance in which the car will stop? So we have 52 kilometers per hour. That is the V0 because it's asking when the car will stop, so VF is going to be 0. And the coefficient of friction is kinetic because the car is moving at 0.116. So first thing we know is that the E, the sum of force in the x direction is equal to m mass times acceleration of the x. And the only force acting on the car in this problem is the friction, and it is acting in the opposite direction the car is moving, so this equals negative F. So negative F for friction force is equal to the mass times acceleration in the x direction. And we know that the frictional force, kinetic force, is equal to the kinetical friction coefficient times the normal force. So we need to find the normal force. And we do that by taking the y force, sum of the y forces is equal to the mass and the acceleration in the y, and since there is no force in the y direction, the acceleration is 0. So this equals 0, and EFY, or sum of force in the y direction, is equal to the normal force minus mass times gravity. So the normal force is equal to the mass times the gravity. And we can plug this in for n, and we get the frictional force, kinetic force, is equal to the coefficient times the gravity. And then we can take this right here and plug it in for this value of frictional force, and we get mu k is equal to UKMG is equal to the mass times the acceleration in the x direction, divide by mass to find acceleration, and the mass will cancel, and we're left with UK coefficient times gravity is equal to acceleration. Oh, this is negative 2 because this was negative. So then we just plug that in to find our acceleration in the x direction. So negative 0 point, right here, 116 times 9.8 is equal to the acceleration x, which in turn equals 9.8. 1.14, negative 1.14. So now we have acceleration, and we can use an equation to find the distance it will stop. So if our V0, its stopping distance, so V0 is 52, oh, we need to switch this to meters per second. So 52 kilometers per hour for 1 hour is equal to 1,000 meters in a kilometer divided by 60 minutes in an hour, 60 seconds in a minute, and we end up getting 52 times 1,000 divided by 60 divided by 60, and we get 14.44 meters per second. So V0 equals 14.44 meters per second. Vf, since the stopping distance, equals 0 meters per second because it will be at rest. Acceleration is equal to negative 1.14 meters per second. The time we don't need, and we're solving for a delta x. So we can use the equation Vf squared minus V0 squared equals 2 times acceleration, change in displacement. So now we would plug in our values here and solve for delta x. And this is 0, so we get negative 14. Well, that will actually cancel. 0.44 squared divided by 2 divided by our acceleration, which is negative 0.114. And we end up getting a value of 91.5 meters. And that will be our answer to our problem. Hope this helps.